Hi guys, so today we're going to go over parallel and orthogonal vectors. I want you to keep in mind that a vector is nothing more than a line with a direction to it. So that means you can still determine if they're parallel or orthogonal using what you learned about lines from algebra. So just a little reminder, in algebra you learned that parallel lines had the same slope. Orthogonal lines were perpendicular, they intersected, they created a right angle, and their slopes were opposite reciprocals, meaning opposite signs as well as reciprocals of one another. Using module 6, orthogonal vectors will have a dot product of 0. So just another addition to what you know about orthogonal lines and now vectors. So using this example for number 1, vector u equals 2, -3. So what I'm going to do is I'm going to go to 2, and you don't have to graph it, but I just want to give you a visual of what's happening with the vector. 2, -3 would be right here. So the vector is just a line with a direction that stops at 2, -3. Vector v is at 6, 4. So 3, 4, 5, 6, and up 4, my vector is here. Again, starting at the origin, it ends at 6, 4. This is vector v, and this would be vector u. So this is what the vector looks like. It's still a line, just has a direction to it. And using what you learned about lines, I'm going to check if they're parallel by checking their slopes. Little algebra reminder, the slope formula was y2 minus y1 over x2 minus x1. Now, if you remember to find the component form, you just did the x2 minus x1 and the y2 minus y1. So that's already been done. So you're just going to take the y over the x value. So for the slope of vector u, I'm just going to take the y over the x. So -3 over 2. So the slope of this line u is -3 over 2. The slope of the vector v is y over x, which is 4 over 6. I'm going to reduce that to become 2/3. So that's the slope for this vector here. Now, these slopes are not the same, so that means they're not parallel. I'm going to check if they are orthogonal. If I look at them, they are the reciprocals of one another. That's when you flip the fraction 3 over 2, 2 over 3, and they have to be opposite signs as well, and they are. One is negative and one is positive. So these two vectors are orthogonal, meaning they create a right angle with one another. Now, using what you saw in Module 6, I'm also going to take the dot product of them just to confirm that they are orthogonal. And the dot product means you take the product of the x values, 2 times 6, and add it to the product of the y values, -3 times 4. And that will give me 12 plus -12, which is 0. And remember, orthogonal vectors should have a dot product of 0, which confirms that these two vectors are orthogonal. And then moving on to number 2, remember that vectors can be written in component form as well as a linear combination. So this is the same thing as me saying 2, -2. The I just tells me which one is the x value, the j tells me which one is the y value, because when you're adding and subtracting, they could switch the order, but you'll still know which one is the x and which one is the y from the variable next to it. So for vector v, remember if there's no number in front of it, it's just a 1. So in this case, it would be -1, and in front of the j is also -1. From here, I'm going to use the algebra method to check if they are parallel or orthogonal or neither. So I'm going to check if they're parallel first, just by checking the slope. So the slope of u is the y over the x, -2 over 2, which would give me -1. And the vector of v equals -1 over -1, which is +1. So These are not the same slope, which means they are not parallel. Um, they are actually orthogonal because keep in mind the fraction form of -1 is -1/1. If I flip that fraction, it still gives me -1/1, which is what I have here, and it's the opposite sign. So these two are opposite reciprocals again, and then if I decide to confirm it by taking the dot product of the two, I'm going to take the product of the x values, 2 times -1, which is -2, plus -2 times -1. -2 times -1 is +2, and -2 plus 2 is 0. So once again, they are orthogonal. If these two ended up being the same slope, then I could just write parallel. I don't know why I decided to do two orthogonals, but just putting that out there, if the slopes were the same, they would be parallel. And if neither one of them happens, then it would be neither. All right, guys.